Hi, ladies and gentlemen. Notes 5.2 are on compound angle formulas. And this reminder that we have up here is going to be useful for you when you work on a bonus assignment, which I will explain what that is very shortly. So what we're going to do is we're going to talk about compound angle formulas. So these are formulas that we can use to find trigonometric ratios of angles that are sums of angles that we already know. So for example, if I wanted to figure out what the sine of 75 was, I can figure it out by doing the sine of 45 plus 30, but because I know 45 degrees and I know 30 degrees, those are some special angles. But I need a formula that I can use that would apply to this to help me find this sine of 75. Okay, but we need to derive these formulas. So the first one we're going to do is we're going to derive the compound angle formula for cosine. And as always, everything always comes back to the unit circle. So we're going to derive it from the unit circle. So what we're going to do right here is we're going to take a look at this unit circle that we have here. This part is cut off, but you don't really need that part anyways. And remember, this right here is 1, 0, okay? And remember, cosine of theta in the unit circle will always be x, and sine of theta in the unit circle will always be y, okay? So remembering that, that's why right here we have this right here is angle theta. That's why this coordinate is cosine theta, sine theta, because it's just simply x comma y. Okay, now if you guys notice right here, we also have angle beta right here. And angle beta is the related acute angle. So right here, we're going to say that this coordinate right here is cosine of beta because cosine is always positive in this quadrant right here. And if you look right here, cosine is, the x value is positive, and the y value right here is negative. So that's why this says negative sine of beta, because again, it's the acute related angle. Okay? Now, I want to figure out how big PQ is. So I'm going to use absolute value bars because PQ is always going to be the length of a side. So I want to find out how big this side is right here. And I'm going to use absolute value because distance is always positive. Now, if you remember the formula for distance, go back way back to grade 10 math. It's x2 minus x1 squared plus y2 minus y1 squared. Okay, so what we're going to do is we are going to call this one right here x2. We're going to call this one right here x1. We're going to call this point right here y2. And we are going to call this point right here y1. Okay, so now that we've figured out what these are, I'm just going to plug in my information into the formula. So the formula, I'm going to take the square root of x2, which is cosine of theta. So I'm going to say cosine theta. Okay, minus x1, which is cosine of beta. So right here, I'm going to say cosine beta. Okay, and then I have to square that. Plus, and by the way, just a reminder, distance formula is pretty much just Pythagorean theorem. Okay, now we're going to do y2. So y2 here is sine of theta. Okay, minus negative sine of beta right here. So it's going to be minus negative sine of beta turns this into positive. So it's going to be sine of beta, and the whole thing is being squared. Okay, and I'm going to simplify this piece right here. So that means that PQ is equal to, I'm going to expand this right here. And when I expand it right here, remember it just means cosine theta minus cosine beta times cosine theta minus cosine beta. I'm not going to go through and spend time worrying about what worrying about how to expand it. If you need to expand it on the side to make sure you understand where I got this from, feel free to do so, but we're not going to spend the time in the video doing that. So right here, when I do this right here, it's going to end up being cosine squared theta. And then remember, it's going to be twice as much as these two multiplied together. So minus 2 cosine theta, cosine beta, and then plus cosine squared beta. That's what this part is right here. Okay, now we're going to do the same thing for this expression right here. So we're going to say plus, and then here we're going to say sine squared theta plus, this right here, we double the product of these two right here, 2 sine theta sine beta, and then plus sine squared beta. Now, if you want to, you can always FOIL this to get this, to see how we got these answers here. Okay, so now let's go ahead and rearrange this in a different order. So what I'm going to do is I'm going to put all the things that just have thetas together and all the things that just have betas together, and then I'm going to copy the rest of it down. So if you notice right here, I have this cosine squared theta. And then right here, I also have this sine squared theta. So I'm going to say cosine squared theta plus sine squared theta. Okay, and I'm done with this term and this term. I've already written it down in my expression right here. Now, I also am going to put my betas together. So if you notice right here, I have cosine squared beta. So I'm going to say plus cosine squared beta. And then over here, I have sine squared beta. Okay, and I'm done with these two right here. And then what's left over is this minus 2 cosine theta cosine beta. And then what I have left over here is plus this 2 sine theta sine beta. Okay, so then one more thing that we need to do in order to simplify this right here. If you guys notice, we've got cosine squared theta plus sine squared theta, and that's equal to 1. And here we've got cosine squared beta plus sine squared beta, and that's equal to 1. So we know that the absolute value of PQ is going to be equal to the square root of, when I add this 1 plus 1 together, I end up getting 2, and then I'm just going to copy the rest of this down. So minus 2 cosine theta cosine beta plus 2 sine theta sine beta. Okay, so now that we've done that, we know what PQ is equal to. Okay, so now I need to follow the next set of directions. So the next set of directions say to rotate the points counterclockwise about the origin so that Q prime is at 1, 0. So if you guys look right here, what I'm going to do is I'm going to rotate this right here this way, and I end up getting Q prime right here is at 1, 0. So right here, what ends up happening is this gets rotated, and now I have a new segment right here. Okay, and because this gets rotated this way, this gets rotated this way right here, and so my new P prime is going to be up here. And since this is my new P prime right here, if you guys notice, this angle right here is equal to this angle right here. They're the exact same size, okay? So that means that this angle right here is going to be equal to theta, angle theta, plus angle beta, okay? Which means that this coordinate that I have up here is going to be equal to cosine of theta plus beta, and then sine of theta plus beta. And that's going to help us get to our compound angle formula here, okay? All right, so now that I've done that, I'm going to do the exact same thing, but this time I'm going to find out what P prime Q prime is going to be. So we're going to split this down the middle because we're going to need a lot of space right here. So to find P prime Q prime, the absolute value of it, same thing, I'm going to use the distance formula that we have right here, okay? But this time, what we're going to have here is that this right here is going to be x2. This right here is going to be my y2, okay? And then over here, my x1 is just 1, and my y1 is just 0. And that's going to make things a lot easier for me right here, okay? So if I were to use the distance formula right here, it's the square root of x2 minus x1. So we know that x2 is cosine of theta plus beta, okay, minus 1. So here we know that this is a 1 right here. And then I'm going to, sorry, I'm going to do this in blue so we can kind of see where this is coming from right here. So I'm going to say minus 1, and then I'm going to square that, okay? Plus, and then I'm going to do the same thing for y2 minus y1, and we know that y2 is sine theta plus beta. So let's color code this purple for us. Sine of theta plus beta, okay? And then right here, I'm going to have minus 0 squared, because the y1 is 0. So I'm going to say minus 0 squared, but I don't need to have that minus 0 there, so I'm just not going to include it at all. So it's just this piece squared. Okay, so let's go ahead and do some simplifying. We'll do some expanding right here. So that means that the absolute value of p prime q prime is going to be equal to, if I were to expand this using FOIL, this would end up being cosine squared theta plus beta, okay? And then this is going to be doubled, so minus 2 cosine of theta plus beta, okay? And then plus 1, okay? And then right here, it's just going to be plus, and then here when I square this piece, sorry, so this I'm just going to color code this so you can see that the pink is this piece right here. And then when I square this piece right here, I end up getting sine squared theta plus beta. Okay, so now that I've done that, I'm going to put together things that might make it a lot easier for me here. So if you guys notice right here, I have this cosine squared theta plus beta, and I have sine squared theta plus beta. And anytime I have cosine squared plus sine squared of the same angle, it always ends up being 1. Okay, so right here, if you guys notice, I'm going to copy this down right here in a different order. Sorry. So I'm going to say cosine squared theta plus beta, okay, plus sine squared theta plus beta, okay. So I'm done with those two terms right here. I'm going to copy down the one next to it. Okay, so I'm done with that one. And then I'm going to copy down just this minus 2 cosine theta plus beta. Okay, and if you notice right here, this ends up being 1. So here I've got a 1 plus another 1. So this ends up being p prime q prime, absolute value of it, is going to be equal to, right here, the 1 plus this one right here ends up being 2. And then I'm just going to copy down this minus 2 cosine theta plus beta. Okay, now if you guys notice right here, when I do this, PQ is this length right here, and P prime Q prime is this length right here. And because the angles are the same, I haven't changed my angles, the lengths that we have here are equal to each other. So that means that PQ is equal to P prime Q prime. So we can say PQ is equal to P prime Q prime. So I'm going to set these two expressions right here equal to each other. Okay, so I'm going to say that the square root of 2 minus 2 cosine theta cosine beta plus 2 sine theta sine beta, remember this right here is just this piece right here, and I'm going to say that that's equal to P prime Q prime, which is this right here, 2 minus 2 cosine theta plus beta. Okay, so now I can square root both sides right here, get rid of the square root. So I end up getting 2 minus 2 cosine theta cosine beta plus 2 sine theta sine beta is equal to 2 minus 2 cosine theta plus beta. Okay, so then I can just subtract the 2 from both sides. They'll cancel each other out. So I end up getting right here that negative 2 cosine theta cosine beta plus 2 sine theta sine beta is equal to negative 2 cosine of theta plus beta. Okay. Lastly, I'm just going to divide everything out by the -2 that's in common right here. So those cancel each other out. These cancel each other out, and these cancel each other out to give us a negative. So on this side, I just end up getting cosine of theta plus beta is going to be equal to, over here, I get cosine of theta times cosine of beta. And then here I get minus sine of theta sine of beta. So this right here is going to be one of the formulas that we can use. So right here, we can say that cosine of x plus y is going to be equal to cosine of x cosine of y, just like we had cosine of theta cosine of beta, minus sine of x sine of y. And with a minus sign here, it's pretty much the exact same idea, except we're just going to say cosine of x minus y is going to equal cosine of x, cosine of y, plus sine of x, sine of y. Okay? Now, if we were to derive a formula for sine of x plus y, you don't have to write this down, but if we were to derive a formula for sine of x plus y and tangent of x plus y, this video would probably be hours long. So your bonus assignment, and I'll give you guys a couple days to work on this, is derive the formula for sine of x plus y and tangent of x plus y. I'll tell you guys the formula on the next page, but I want you guys to derive a formula for it. Okay. All right, so now here are the formulas that we will use for sine of x plus y and sine of x minus y, tan of x plus y, and tan of x minus y. So sine of x plus y is just going to be sine of x, cosine, sorry, of y, okay, plus cosine of x, sine of y, okay? And vice versa, sine of x minus y is just going to be sine of x, cosine of y, minus cosine of x, sine of y. So if you notice for cosine, we put the two cosines together and the two sines together. For sine, we put sine cosine of one and then the other, and then we do the opposite here. And same thing over here. And notice that the signs are going to be swapped. The SIGN signs are going to be swapped. Okay? And then tangent of x plus y might look scary, but it's not so bad. And the formula for that is going to be tan of x plus tan of y over 1 minus tan of x tan y. So we're going to multiply these guys together. And then tangent of x minus y, you just change the signs. So this is going to say tan of x minus tan of y over 1 plus tan of x tan of y. Okay? And I'm just going to rewrite this a little bit more clearly so you can see that this is minus tan of y. Okay? All right, so now we need to know how to actually apply this information. So question number 1 says express as a single trigonometric ratio using an appropriate compound formula. So if you guys notice right here, cosine of theta, cosine of 2 theta is like cosine of x, cosine of y, minus sine of theta, sine of 2 theta is like sine of x, sine of y. So essentially, all this is saying is it's just cosine of x plus y. So it's cosine of theta plus 2 theta. So this ends up being cosine of 3 theta. Okay? All right, so now for the next one right here, it's tan of pi over 3 minus tan of pi over 4, just like we have tan of x minus tan of y, all over 1 plus tan of x tan of y. So that means that this will end up being tan of x is like pi over 3 minus pi over 4 because y is like pi over 4. So I'm just going to figure out what is pi over 3 minus pi over 4. Well, my common denominator is 12. So I'm going to multiply this by 4 over 4, and I'm going to, 3 over 3, and I'm going to multiply this by 4 over 4. So I end up getting 4 pi minus 3 pi all over 12. So this is going to just be pi over 12. So right here, this is just equal to tangent of pi over 12. And that's my answer for this one right here. All right, so for question number 2, it says determine the exact value for each using the compound angle formula. So right here, sine of 13 pi over 12, what I want to do is I want to look for numbers I can add together to give me 13 over 12. So I could do 1 over 12 plus 12 over 12. But 1 over 12 is not an angle that I know, so that's not going to be useful. Okay, or 1 over 12 pi, right? The ones that we know are multiples of any of these. So 0, pi over 6, pi over 4, pi over 3, or pi over 2. Okay, so I don't want to use that. So I could also do 2 over 12 plus 11 over 12, and 2 over 12 gives me 1/6, so I could use this, but 11 over 12 doesn't give me anything nice, so I'm not going to use that, okay? I can also do 3 over 12 plus 10 over 12. Okay, so 3 over 12 right here, if I were to use 3 over 12, I know that 3 over 12 will reduce to 1/4, and we know that 10 over 12 will reduce to 5/6, which is a multiple of this pi over 6, so this could be a possibility that I could use, okay? Let's take a look at one more. We could also do 4 over 12 plus 9 over 12 right here. Okay, and if I were to use 4 over 12 plus 9 over 12, I know 4 over 12 will give me 1/3, and I know 9 over 12 will give me 3/4. So I've got these multiples right here, so I could use this one as well. It's up to you which one you want to use. I'm going to use this one right here. Okay, either way, you should get the same answer, the right answer. So now let's take a look at what the formula says. So the formula says sine of x plus y is equal to sine of cosine y plus sine of x cosine y plus cosine of x sine of y. So I can say right here, sine of, and you're going to probably want to write small, sine of x plus y is equal to sine of x cosine of y plus cosine of x sine of y. And here, instead of using sine of 13 pi over 12, I'm going to use the sine of, right here, 4 pi over 12 plus 9 pi over 12. But I know that 4 pi over 12 reduces to pi over 3, and I know that 9 pi over 12 reduces to 3 pi over 4. So this is going to be equal to pi over 3, sine of pi over 3 plus 3 pi over 4. So that means that I'm going to end up getting sine of pi over 3, cosine of 3 pi over 4, plus cosine of pi over 3 times the sine of 3 pi over 4. Okay, so let's take a look at what we have using the unit circle. So using the unit circle right here, I know that pi over 3 ends up being more along the lines of being right here. Sorry, let's get rid of that. And so right here, when I look at this angle right here, I know that this right here is pi over 3. And I know that pi over 3, the coordinate of pi over 3 is going to have to be 1/2 comma root 3 over 2. Okay, and then for cosine of 3 pi over 4, I know that this is where 3 pi over 4 is. Okay, from here all the way to here is 3 pi over 4, and I know that this coordinate is negative root 2 over 2, root 2 over 2. So I can fill in all of that information right here. Okay, so let's go ahead and do that. So this is going to be equal to, so now when I do this right here, if I do sine of pi over 3, remember sine is always the y value, so it's going to be root 3 over 2 times the cosine of 3 pi over 4, that's the x value right here, so that's going to be negative root 2 over 2. Okay, then I'm going to say plus right here. Now I'm going to find the cosine of pi over 3. So the cosine is my x value, so it's going to be 1/2 right here, okay, times the sine of 3 pi over 4, and the sine of 3 pi over 4 right here is root 2 over 2. Okay, so this ends up becoming right here. 2 times 2 is 4, 2 times 2 is 4, so I have a common denominator of 4. And then root 3 times negative root 2 is negative root 6. And then 1 times root 2 is positive root 2. I can't simplify these, so this is going to be my final and exact answer. Okay, now if you were to go to your calculator, so we'll type in calculator right here. If you were to go to your calculator and make sure that you are in radian mode, and if I were to take the sine of 3 pi over 12, so I'm going to take the sine right here, I get negative 2.588, okay? So right here we can say that this is approximately equal to negative 2.588. And then let's plug this expression into our calculator, this one right here. So I'm going to take the square root of 6, make it negative, plus the square root of 2. Enter, divide that by 4, and I get the exact same answer. This is not the exact answer. This is the rounded answer. This right here is our exact answer. Okay, so let's take a look at question B. Right here it says cosine of negative 15 degrees. So to get negative 15 degrees, I'm going to use some nice numbers that I already know. So I'm going to use 30 degrees minus 45 degrees. So what I want to do here is, in order for me to get this cosine of negative 15 degrees here, I'm going to use the subtraction formula that we have up here. So I'm going to say cosine of x minus y is equal to cosine of x, cosine of y, plus the sine of x, sine of y. Okay, so then once I do that, what I'm going to do is I'm going to say right here that I'm going to do cosine of 30 minus 45, and that's going to equal cosine of 30, cosine of 45, plus the sine of 30 times the sine of 45. So I'm going to go into my unit circle, and I'm going to draw in my 30-degree angle, and I know at my 30-degree angle, my coordinate is root 3 over 2, 1/2, and then I'm going to draw in my 45-degree angle, and I know at 45 degrees my coordinate is root 2 over 2, root 2 over 2. So I'm going to plug in that information right here. So here I'm going to say cosine of 30 is always going to be the x value right here, so it's going to be root 3 over 2. Okay, and then cosine of 45 is the x value right here. So this x value right here is root 2 over 2. Okay, then I'm going to say plus, and then over here, the sine of 30 right here is going to be the y value here. So it's going to be this 1/2. Times the sine of 45 is going to be this y value right here, so it's times the square root of 2 over 2. So I end up getting right here that this is all equal to, again, my common denominator is going to be 4. So then in my numerator right here, I end up getting root 6 plus, because root 3 times root 2 is root 6, and then 1 times root 2, so plus root 2. And this right here is my exact answer. And it should make sense to you that this will end up being a positive value because cosine of negative 15 will be down inside of here, and we know that cosine is positive in this quadrant. Okay, I think that's enough for this video. So questions 3 and 4, we're going to take up together as a class. Okay, all right, that's it. Have a great day, and I will see you next class. Bye.